Hey guys, so I was asked to make an explanation video on problem 3 from the local contest thing, the really hard questions. So this one was like, it had like triangles. I just split up the diagram to make it look easier because on the sheet it looked very confusing. But if we just split it up into these pieces over here, it's not that hard actually. Okay, some other information that they told you was that this length EA was 546.64, I believe, and over here the length was 418.81. And they also told you a couple of other things. They told you that this angle over here, let's call it phi. They told you that phi was equal to, let's see, phi was equal to 60 minutes, not 60 minutes, 60 degrees, 13 minutes, and 36 seconds. Okay, they also told you that this angle over here, let's call that psi. Let's call that psi is equal to 67 degrees, 20 minutes, and 10 seconds. Okay? Next, what else do we know here? We also know that this angle over here, let's call it alpha. Alpha is equal to 33 degrees, 26 minutes, and 21 seconds. A couple more to go. We know that this angle over here, let's call it gamma. No, let's not call it gamma. Let's call it beta. Beta is equal to 47 degrees, 40 minutes, and 32 seconds. Lastly, we know that, what color should we use? Okay, blue. We know that this angle, now let's call it gamma. Gamma is equal to 44 degrees, 5 minutes, and 13 seconds. Just for clarification, I'm using these symbols for accuracy because I don't want to write all these numbers all the time because it's just going to get repetitive and no one likes that. So I'm just writing these symbols as variables to instead of these degree measurements. So now we need to make some progress in solving this problem. So they're asking us to solve for AB, first question, and we can't really do that yet for a couple of reasons. So first, what we should do is solve for this whole length AC, and after we solve for AC, we can solve for BC, subtract those two quantities, and then a result will give us AB. You know, because AC minus BC, the remaining term is AB, right? So, and solving for AC is pretty easy because we already know EA, we know CA, so we can use the law of cosines there. So what are we gonna get? We're gonna get, so we can get CA squared. So CA squared is equal to EA squared plus EC squared minus 2 times EA times EC. This is just the law of cosines times the cosine of this obtuse angle over here. And what's this obtuse angle? It's beta plus alpha plus gamma. Nothing hard over here. We're just doing the law of cosines for this really big triangle over here. This one. Right? Nothing bad. So now if we substitute our values for EA as 546.64, for EC as 418.81, same thing over here and here, and we substitute beta for 47 degrees and this, so substitute alpha for this, and we substitute gamma for this, we're going to get a number. And if we square root that number, because we have a CA squared here, but we just want CA, we're going to get CA is equal to 859.164 051. Okay? Nothing too crazy. So what does that mean? That means this whole length over here, CA, is 859, right? And our goal was to solve for AB, this thing over here. So now we need to find BC. How can we solve for BC? Simple. To solve for BC, we just think of the law of sines, right? And the law of sines says that sine of A over A is sine of B over B, right? So we can apply this to this situation. We have this side here in purple, and it's opposite of the side of 418.81. And then we want BC, right? So what's the angle opposite of BC? Well, that's just this obtuse angle over here, beta plus alpha. So let's do the law of sines for this to solve for BC. So we get that sine of psi, that's that first one, divided by its opposite side, which is 418.81. That's equal to sine of beta plus alpha, sine of beta plus alpha, because that's opposite of BC, which is what we want to find, right? And now, let me just scroll over a little bit. Now, if we cross multiply, we'll get, what do we get if we cross multiply? BC sine of psi is equal to 418.18 times sine of beta plus alpha. Okay? Let's divide through by sine of sine of psi on both sides, because in the end we want BC, right? So we get BC is equal to 418 divided by 418.18 sine of beta plus alpha divided by sine of psi. Okay? Now, what's beta and alpha? We already have those. It's right here. 47 degrees for beta, and what's alpha? Alpha is 33 degrees. And what's sine of psi? Psi is 67 degrees over here. So this makes it easy because we can just plug in the numbers into a calculator, and our calculator is going to spit out our answer. So BC is approximately 448.41. Not that hard at all. You're just substituting values into the equation. And now this is great. We have AC, 859.16051. What else do we have? We have BC now, which is 448.41. So now we can finally solve for our goal. Our goal was to find AB, right? So AB, as we all know, is equal to AC, not AC, or you could rewrite it as CA, subtracted by BC, and so thus AB is approximately equal to 410.76. So we already solved the first two parts of this problem, solving for AB and BC. But now we have to find the third part, which is solving for, let's see, what do we solve for? Yes, we're solving for BD over here. BD. Alright, so when we solve for BD, we have to be a little tricky with our approach, because we don't really have any side lengths to solve for BD. Because, like, consider we're looking at this triangle over here. We need to find the side length of something, because right now we have nothing. So let's start off by finding the side length of this here, BF. So how can we find the side length of BF? Well, here's a little trick. We know that this whole thing over here is, what is it? This is BC. We found BC, right? It's 448.441. So now if we can find the side length of FC, we can subtract that by the side length of BC, which is 448.41, and that's going to give us FB. Okay, now we just have to do this. So how do we find CF over here? Well, we have this angle over here, which is EFC. And can we represent that as any of these variables that we have over here? Yes, we can. Because look over here. FEB right here is alpha, FBE is psi, right? So that means this angle over here, since the sum of the angles in a triangle is 180, that means alpha plus psi plus that angle is equal to 180. So we can say that this angle is equal to 180 minus psi plus alpha, right? Because look, alpha psi plus this angle is 180. Now if we subtract, we want to have it by itself. Okay, let me show you over here. Oh, let's call this angle x. So we have x plus alpha plus psi is equal to 180. And we want x by itself. So x would be equal to 180 minus alpha minus psi. And if we distribute this out, we're going to get the same thing. 180 minus psi minus alpha. Okay, so now we have that. So now, but we want this angle over here, as I mentioned, angle EFC. And to find angle EFC, let me just write this over here. EFC and angle EFB are supplementary angles, right? That means their angle measurements sum up to 180 degrees. So we can write that angle EFC, which is this angle over here, that is equal to 180 minus this angle over here, which is x. Remember, EFB, we denoted that as x. And what is that? That's 180 minus alpha minus psi. So this is equal to, these two cancel out. So, and then distribute that, and distribute that. So that's equal to alpha plus psi, which is angle EFC. So that's great. Now we can finally do the law of sines, because we get that sine of alpha plus psi, which is this over here, and then its opposite side is 418.81. 418.81. Oh, by the way, over here this should be 418.81, not 418.18. That was a little typo by me. Sorry. Alright, so that is equal to, we want to solve for CF, right? And what's the opposite of CF? Well, that's angle beta. So that's equal to sine of beta over CF, which is what we want to solve. And again, we use the same process of cross multiplying. We get, let me just tell you what it is. So CF sine of alpha plus psi is equal to 418.81 times sine of beta. And CF is equal to 418.81 sine beta divided by sine of alpha plus psi. So, and then at the end, if we plug in all the numbers for beta, alpha, and psi, we get CF is equal to 315.2. Okay? And this is really good, because now we can solve for our goal, which is FB, because we know that FB is now equal to CB, or BC, which over here is 448.41, minus the thing we just found, FC, which is 315.2. So if we do this, then we get FB is going to be equal to 133.21. And that's really good. So now we can finally solve for our last angle, right? So consider this triangle FBD over here, right? So if we, let's look at it. If we have sine of angle D over, what's its opposite side? We just found this, FB, over 133.21 equals, we want BD, right? So what's its opposite angle? It's angle right here. It's DFB, which is the same thing as this because it's opposite angles. And opposite angles are equal, right? So that's going to be equal to sine of alpha plus psi. Over here, same thing. And that's over what we want, which is BD, right? And now if we solve for BD, we'll get that BD is equal to 401.98.